Hello everyone and welcome to another Würth Elektronik webinar. My name is Silas Zorn and I will moderate this webinar today. We are very pleased that you took the time to participate in our webinar. The topic of today's webinar is Simplify Filter Calculation and Selection with REDEXPERT EMI Filter Designer. Our speaker today is Schillinger, who is working as a field application engineer at Würth Elektronik ISOs. Robert, good morning.
Good morning.
Welcome. So, before we start with the webinar, I would like to point out one thing. You will be muted during the webinar. This means that you cannot ask us questions via your microphone. But you have the chance to ask your questions during the webinar at any time in the chat function. We will answer them in a short Q&A session after the presentation. So, last information for you. You will all receive the link to the recording as well as to the presentation of the webinar in the next days via email. So now I will hand over to you, Robert.
Yeah, thank you.
So.
Okay. Thank you again, Silas. And now I will start with my presentation. Today I will speak about our filter designer, which is a part of our online tool REDEXPERT. You can find via our homepage, or you can write it directly in your browser, redexpert.com. Then you also get the link. I also add a slide with a demo button into the presentation, which you will also get after the session here. Then you can do it by the PDF directly and can follow my presentation today in the live tool. Yeah, what is the basic, what I will show you for the filter designer and how it works. We need a noise source, and best noise source is switch mode power supply. And I select one of our eval boards with a Power Magic module on it. And I will give you a short introduction what the eval board is doing. And for this I will show you here the input value. You can use this eval board for input voltage from 7 up to 50 volts. You can supply electronics in a range from 2.5 volt up to 15 volts at maximum 2.5 amps. And you can configure it. You have standard voltage values. You can see here like 15 volts, 5 volts, 3 volts for example, and you can select by the jumper you see in the picture. What is also possible, you can select voltages outside these values. In this case you must change the feedback resistor divider to select, for example, 3.5 volt if you need this voltage. And the next selections are based for the switching frequency. You can change here also in a wide range. And if you like another switching frequency, then you must change also on the board the resistor, which is used or selected this switching frequency. In our case, for the board, 5 volts out is selected and 800 kilohertz are selected. What we have also on the board is this red area where you can see an assembled filter capacitor and in shortcutted filter inductance, in this case without filtering, to see what happens on the input side if you measure like in an EMC lab conducted emissions. That's the reason behind, and you have the possibility to insert here some components for filtering and try it out what happens if you insert such components. Yeah, that's the simple working place with a conducted plan, which is in this case not urgent needed, because we don't have a look on the differential mode of this board, we only have a look on the common mode. And for this we supply the system via a DC listen, which is able to switch out the noise which is coming from the board itself via the lines here, and block it back to the power supply, and the noise comes out on channel A or B. A is corresponding to the plus line, and B is corresponding to the minus line of the supply. And then with an spectrum analyzer, oscilloscope with Fourier transformation functionality, or an EMI receiver, you can have a look on the typical conducted emissions. On the other side, you need a load. In this case, I use an electronic load, which is selectable to 2 amps, 2.5 amps, whatever you want. And you can change it. You can do the same with a simple load, with a resistive load, by power resistors for a load. Yeah. What happens on the conducted emissions? We see a typical diagram from 150 kilohertz here on the left side up to 30 megahertz on the right side in logarithmic scaling, and we have here at 800 kilohertz, how expected, the 800 kilohertz base frequency of the switch mode power supply, and we can also see very nice the harmonics, or one of the harmonics at the double frequency of 1.6 megahertz in this case. Yeah, what we like to have, we have here 76 dB microvolts noise on the line. That's too much. It's wide below the borderlines, and we have a first look on the average line, which is for the B specification at 46 dB microvolts. And what we expected in designs we support, we say please go around 10 dB or minimum 10 dB below the borderlines, because of tolerances of EMC laboratories, of components, of everything around such systems. You need a huge space between the line, the limit line, and the rest of the noise, because if anything is changing and you are too close to the limit line, then you can get trouble maybe. That's the reason why we said say please 10 dB below, and in this case we need around attenuation of around 40 dBs. That's the slide with the demo button. You can click it and switch to the browser, to your browser, and link to the filter designer itself. Today I will show you only the windows and parts of the filter designer in the following slides. If you click the button, then you change your the website and you come to this part here, and you see in the top the EMI Filter Designer. You can click it and get a second page where you can start with all settings you need for your filter. And at first, the system impedance is important for the power transfer to select the right impedances. In this case, the 50 ohm for the listen, and the noise source should be or is in most cases very, very low, around 0.1 ohm. In this case, you can lower this down to 0.01 or what else, and you can play with it, and maybe you can try 100 ohm. Then you will see some differences in selecting the topologies. Then you have here two possibilities to select or to come to the selection of your topology. You can select in one part the cutoff frequency. If you know how you come to the cutoff frequency, you can put it in here directly, or you can use the attenuation of around 40 dBs in the case we have here, and at the frequency we have at 800 kilohertz. So you can change every parameter here, and from our example we have here 40 dBs and 800 kilohertz, and then you will get the fitting topology caused on the impedances. If you go to the next step, then you will see the calculated component values for this settings, an L and C, and here in the table what values they have, how many milliohms or ohms the components have inside, and you will get here the calculation of ideal components in caused by a simple formula, but you get also an attenuation at the specific frequency with real components, with all parasitics, to see is the attenuation enough or not. And you get also here the simulated curves, also with also done by real components. The last diagram here, it's an important one, because here you can see the output impedance or the for stability criteria. You see the output impedance of your filter, and you can compare it with the input impedance of your switch mode power supply. And if you compare it together and see if anything too close together, then you can thought about if you have stability problems. That's the first point to see it. Another point is to build the electronics and take or make a Bode plot, or a step response measurement. That's the possibilities. But always, if you insert frequency dependent components for filtering in a switch mode power supply design, then please check the stability. If you have, or if the suggested components not the right ones and you like to change it, then you can do it also by clicking this button, this change button here on the finger, on the cursor here, and then you come to another mask in which you can select other components. In this case you can select some capacitors, and you can select it by different colors, get the characteristics of these components in the same color on the right side to compare it together. For example, MLCC with a polymer capacitor to see the effects. You get also a column where you can see for MLCC especially the DC bias influence and what or how many capacitance at your working point is reached there. And you get also the archived attenuation and can compare it together with each of these components. And the same here in the characteristics. That's all possible with the filter designer. You get a lot of information. Then you come back and click Add More, and every one which is selected in this list you can add to the simulator and come back and select here again. And you have also a lot of possibilities to find the right component. You can, if you know a part number, then you can filter here by part numbers. You can filter here by capacitances. You have a lot of possibilities. Also, the rated voltage is important. You can also filter by this. And then, the components get less, more, less. And at the end, maybe you have 5 pieces in your selection or as possibility, and then you have a good solution to start with your work. With this button, you bring the selected ones back to the filter, and what you can also do with the filter designer, you can have here this summary. Then you have see here kind of part list, the bill of material only of the filter. You see the calculated impedance curve of this filter, some other curves, and you can have a look on all parameters or which are characterize the filter. With this button you can add the components to your basket and order it via mail to get the right components and put it on the PCB. With this button or with this logo, it's a printer, you can see. You can documentate the whole work, your whole work, all the slides we see before. You can print into a PDF, and you can download the PDF and put it to your documentations. That's the end of our filter. Now we have 2 components. We have selected in the hope that it helps for our noise we see at the beginning of the presentation. And I inserted it into the evaluation board and do the measurement again. And now we see 800 kilohertz here. We drop down this peak right below the limit line. This one we see at the beginning also. It has no influence. Maybe it could be a common mode noise, which we can have a closer look on it, but not in this presentation today. But this could happen that it's not a differential mode noise, a classical. It could be a common mode noise. For this, the LC filter doesn't work for this noise, and we can't drop it much more. In this case, we should use or must use a common mode choke. But remember at the beginning we have 76 dB microvolt at 800 kilohertz. Now or our target was 36 dB microvolts, and we see we are below our target. We come to 8 dB microvolts with our filter. It's much more than we can expect. And for this, everything is fine. We are through the conducted emission measurement in the lab, and everything is good. And yeah, with this I will end the presentation, and yeah, hope you learn something more about this and have a good tool and use this tool in the future. And if you have any questions, then feel free to come back to us and ask this. You can do it by the sales guys. You can do it directly via the responsible FAE, or use our email addresses to contact with us. Thank you very much.
Yeah, thank you, Robert, for the interesting presentation. So now we will come to your questions, and we'll start with the Q&A session. So I think we can directly start.
Yeah.
First question, do I have the possibility to support you with new ideas, improvements?
Mm-hmm. Yes, that's always possible, especially for this tool, for the REDEXPERT and the designer tool inside the REDEXPERT, and all other tools which are coming with REDEXPERT. If you have good ideas, improvements, if you found a mistake also, then please come to us. It's our software, it's our database, and you can bring you in to our development, and we write on a list. List is huge, but we put your ideas in this list, and we try to help you in this way.
Cool, thank you. Next question, is it possible to pre-select the use area of the filter?
Not at the moment. I think you go in the direction of can we build a kind of courtyard you use for the filter, the space for the filter, but it's not possible at the moment. Maybe in the future. Maybe it's one of these good ideas we can insert, but at the moment it's not implemented and not possible.
Okay. Next question, why recombinant filters for SMPS? It is in most cases inside of a device.
Mm-hmm. Yeah, that's a good question. I hear it a lot of times from a lot of customers. Why should I do this? It's inside. I have outside a power supply from AC to DC, for example, and then a mains filter. I have no problems with it. That could be all correct, but sometimes you have in your design noise source, and nobody knows what happens with coupling effects. And maybe you see the high 800 kilohertz peak in the design, and if you let it be there, then no one knows what happens. It can convert from the differential mode to a common mode, and if you have communication lines, for example, with long lines outside, then you have a nice antenna for such common mode noise, and you can get trouble in radiated emissions, for example. And noise reduction far away from sources are from my experience side, always very hard to handle. It's not so easy to find it, to reduce it. You must use huge components like snap ferrites outside. It's not so nice. It's hard to reduce, and in most cases very expensive. And in my mind, the better way is to use two simple and cheap components in front of such switch mode power supplies and reduce the noise directly there where it comes from. That's my mind for this, and I do it and I try it to bring it to you to make it in a correct form. But in principle, you're right. It's not possible. It's not necessary directly. But if you are thinking ahead, then it makes sense.
Cool. Thank you for the answer, Robert. So now we are finished with the webinar today. If there are any questions left, we will answer them. Robert will answer them via email in the next days. So yeah, thank you very much for your attention. I hope you enjoyed it. And so now I hope you will hear us in the next webinar, and I wish you a good day. Bye bye.
Thank you. Bye.